guys, Mr. Gucci here, making his help video for the 4.3 homework electron configuration orbital notation. So first things first, let me just blow this up. Now I am doing this homework in Microsoft Word, as you can see, and I'm going to be using my writing pen here to make this whole process go a little bit more quickly for this video. Now you guys, we'll be doing it in a digital document where I don't think you can write, you just got to type things in, which is totally possible. I've given you the option to copy and paste a bunch of things in to fill in these boxes. But me, I'm going to be writing these in with my pen just because that's going to make things a little bit easier for me. Okay, so first things first, on this first page you have questions about the Aufbau principle, Hund's rule, and Pauli exclusion principle. Okay, you're going to need to get those from your notes. But what you are going to need to do is you're going to need to fill in this Aufbau diagram right here. Okay, so again, this Aufbau diagram. Aufbau is just German for, I think, ordered or sequence. Okay, so you just have to fill in the Aufbau diagram. So here's how it goes. It's here 2s, 3s, 4s, 5s. So these are the different energy levels. Okay, 7 energy levels that we've discovered so far in atoms. All right, the first energy level just has an s. All right, the second has energy level has a P and an S. So 2P, 2S. And every other energy level afterwards also has a P. So it's here 3P, 4P, 5P, 6P, 7P. All right, starting in the third energy level, we have a D sublevel appearing. All right, that holds 10 electrons. 3D, 4D, 5D, 6D, 7D. And then starting in the fourth energy level, we have the F, which holds 14. All right, 5F, 6F, 7F. So this diagram right here is called the Aufbau diagram. And it's not a real thing in nature. It is just a neat trick that scientists came up with to help us remember the order in which electrons fill into sublevels. So here's how it works. We're going to draw some diagonal arrows. The first thing we're going to do is we're going to fill the 1s, all right? Then we're going to fill the 2s. Then we're going to fill the 2p, then the 3s. Then the 3p followed by the 4s. Then the 3d, 4p, and 5s in that order. Notice how we're going and we're filling in to higher and higher energy levels, even though there's still available space in lower energy levels. Oopsie. Undelete. Undelete what I've deleted. Oh, God. This is why I don't like doing things in Google or Microsoft Word. Oh, my God. Okay, let's see here. Okay, let me just fix this. Let's see here. That's 4F, 5F. Okay, cool. So notice how we're filling into the 5S. All right, we're already filling into the 5th energy level. All right, but there's still space in the 4th energy level, and that's okay. The reasons why electrons will fill into higher energy levels when there's still space available in the lower energy levels is because they don't like to be crowded, okay? So here we go. So this is the sequence of the Aufbau order, okay? So it starts with the 1s, followed by the 2s, followed by the 2p, followed by the, let me just draw this in here. All right, so the 1s, followed by the 2s, followed by the 2p and the 3s, followed by the 3p and the 4s, followed by the 3d, 4p, 5s, 3d, 4p, 5s, followed by the 4d, 5p, 6s. All right, 4d, 5p, 6s. All right, followed by the 4F, 5D, 6P, and so forth. Okay, I'm not having you do the whole thing. You're just stopping at 6P because I cannot possibly see us getting farther than that. Okay, so there we go. That is the Aufbau order. Okay, and then it continues onward to the 7S and the 5F, the 6D, the 7P. Mr. Gucci, why does it end here? Because at this point, we are out of elements. There is no element that goes here. All right, we are officially out of all known elements. Okay, cool. So that's the Aufbau order. So let's take a look at your actual homework, which is to fill in these electron configurations. Now, the steps are straightforward. Okay. By the way, these names here, these are not the same ones you have. So don't copy this directly, okay? I am using slightly different elements, all right? But this process is going to be the same. So here we go. What you need to do is go to a periodic table and look up how many electrons this element has, okay? Its number of electrons is just going to be its number on the periodic table. All right? Because this is not an ion, so we just assume that its number of electrons is going to be the same as its number of protons. Okay, so let's find nitrogen on the periodic table. Nitrogen, nitrogen. Here we go. Nitrogen is element 7. So it has 7 electrons. Okay? Now we fill in. We have to configure 7 electrons. So we start with the 1s, okay? And we fit 1 electron, 2 electrons. All right? Then the 2s, 3, 4. Then the 2p, 5, 6, 7. Okay? This is how you do it. You fill in one sublevel at a time. Okay? One sublevel at a time. And you don't double up electrons into these orbitals until every orbital has its own electron. Okay? Don't double up arrows in a box until every box has an arrow in it already. Okay? I like to think of it as like the bus rule or the urinal rule, where like you're not going to stand next to someone at a urinal if there's a whole bunch of free urinals somewhere else. You just don't do it. It's against the rules, all right? Electrons want space just like we want space, okay? This is technically Hund's rule. Hund's rule says that electrons don't double up. So there we go. This is the configuration of nitrogen. All of these other sublevels out here are empty. All right, there's nothing in them. We don't have any electrons for them, okay? This nitrogen has 7 electrons, so it puts 2 into the 1s, 2 into the 2s, and 3 into the 2p. All right, that is 1, 2, 3, 4, 5, 6, 7 electrons, okay? Let's take a look at calcium, all right? The next one. Calcium is element number 20, all right, which means that it has 20 electrons, assuming it doesn't have a charge, which that's the assumption we're going to work with here. All right, number of electrons, 20 electrons. So here we go. We are going to fill each sublevel in the Aufbau order, one at a time, filling it up, all right? And then when one gets filled, we move on to the next. So here we go. Up, down, that's 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There we go. That is the electron configuration for calcium. It ends with 2 electrons in the 4s sublevel. And that's it. The other ones are empty. All right, they are empty because we're out of electrons. This atom only has 20 electrons, and we have now placed them all. Okay, very good. By the way, this thing here where I'm like clearing this out and like whiting it off, what did I just do? Control Z, undo. All right, where I'm clearing this out, you don't have to do that. All right, this is just something I'm doing to make it easier and more apparent to you what's going on. All right, next up, element number 8, silicon. Okay, element number 8, silicon. Silicon is 14, element 14, so it has 14 electrons. Here we go. All right, here we go. 14 electrons. And we're going to start filling them in the Aufbau order. All right, so we're going to start with the 1s. It gets 1, and now it can double up 2. 1 doubles up 2. So 1, 2, 3, 4. All right, single, single, single. Now we double up, double up, double up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of them. All right, single and double up, single, single. This is the electron configuration for silicon. Once again, we don't fill up any of the other levels because there's no electrons left. we don't even finish filling up this 3p because there were only 2 electrons left at that point. So that is the electron configuration of silicon. Let's try another one here, okay? Another one, chlorine, all right? What number of electrons does it have? I go to the periodic table and see chlorine has 17 electrons. 17 electrons. So here I go. 17 electrons. So here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oopsie. We got to go different ways. That's the Pauli exclusion principle. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, that is the electron configuration for chlorine. You just keep filling in electrons until you've placed all there are and there's no more left to place. There we go. That is the electron configuration of chlorine. Now, I think I'm going to stop this video here and then make a part 2 coming up next. Here we go.